One sample hypothesis test. This is a proportion problem. Product loyalty. Toyota Motor Corporation claims that at least 60% of their customers are willing to buy another Toyota vehicle. You took a random sample of 200 Toyota owners and found that 110 of them are willing to purchase another Toyota. The significance level is 1%. The question is there enough evidence to reject the claim? How do you know this is a proportion problem? Proportion problem is always easy. You get two numbers from the problem. Number one is the sample size. Number two is the number of success. So in this problem, the sample size n is equals to 200. So there are 200 customers, and then the number of success is equals to 110 of them. And then you can set up your sample proportion p hat. So the p hat is equals to x divided by n, which is equals to 110 divided by 200. Oh, in some textbook they don't use the p hat, they use p prime. That is the same thing as p hat. So p hat and p prime, they are both sample proportion. Just draw a little hat above the p. So let me make the hat look nicer to you. So this is a p hat. So we call this a p hat. What is p hat? So p hat in statistics, every time you add a hat, that means estimation. So p hat is an estimation of the population proportion. Population is big, sample is a piece of the population, so you are using the sample proportion to estimate the population proportion, right? That is what you study in confidence interval. So p hat is based on the sample. P, which is 60%, is based on the entire population. So the p naught is equals to 60%. Let's put this in decimal, 0.60. All right. And then one other thing that you will have to do is usually you have to say that the sample proportion, so this sample proportion can be approximated as, or you can say that follows normal distribution with the p 0.60 and then standard error. So this is the square root of let me write the formula for you. The square root of p naught 1 minus p naught divided by n. So that will be 0.6. 1 minus 0.6 divided by 200. So when you fill out the blank, you have to say the sample proportion. Sometimes they use p prime that follows normal distribution. The population proportion is 60%, and then if you do the math right, that is equals to 0.0346. They usually ask you to keep 4 decimal places, 4 numbers on the right hand side of the decimal point, 0.0346. And then now you can set up your H naught and HA. So the H naught is in the first sentence, they said at least 60%. So that will be H naught. At least means 60 or above. So the true proportion P is equals to 0.60. Oh, it's not equal to. It's greater than or equal to. So that will be greater than or equal to 60%. So this is 0.60. And then HA, they didn't give you a sign for HA, so we will just take the opposite. And then HA is P less than 0.60. And then the next step that we will have to do is we will have to calculate the test statistics and report the p-value. So thus, to calculate the test statistics, the formula is this. So you have z equals to, so that's why we said that follows normal distribution. And then you use p hat minus p naught and then divided by the standard error. P naught 1 minus p naught divided by n, and then of course you get this from the calculator and then the p-value. So on your calculator, where do you go? You go to stat. So you hit the stat key and then you are looking for one proportion z-test. On my calculator on the left, that is line 5, one prop z-test, one prop z-test on line 5. So you select one prop z-test, and then when you do one proportion z-test, there is no data option, because for proportion problem, you do not need any data. You only need 2 numbers, an n and the number of success. So the p naught is equals to 0.60, and then x is 110, and then n is equals to 200. Oh, when you write the sample proportion, do not reduce the fraction, do not approximate that to decimal. You don't need to do it. And then which symbol should I choose? Not equal, less than, or greater than. We should choose less than, because in HA, we have a less than, and this less than determines the p-value. So less than means it's a left-sided test, so the p-value is on the left. The alpha, the rejection region, is also on the left. I will draw a picture for you. And then after everything is ready, you have two options. You either calculate or draw. So let's calculate first. So we have a 0.6, 110, 200, less than, and let's calculate. So you have the test statistic equals to negative 1.443. I like 3 decimal places, and then the p-value is 0.0745. So that is greater than 1% alpha, so therefore we fail to reject the null hypothesis. What if you click the draw option? So if you click the draw option, this is what you will see. So you will see a bell curve, and then the mean is right in the middle. So the bell curve on your calculator is centered in the middle. So you have the mean right in the middle, and then you have negative 1.443, right? So negative 1.443 is around right here. So this is Z equals to negative 1.443, and the name of the negative 1.443 is called test statistic. And then the p-value 0.7 is the entire orange region. So that is the p-value, 0.0745. And then where is the rejection region? You do not see that on your calculator. So the rejection region, you have to write that yourself. So do we agree that the 1% is less than the orange region? Yep. So that means you put the 1% in there. So the 1%, the cut should be right over here, and then here is the rejection region. So using the p-value to make a decision, you say p-value is greater than alpha, so you fail to reject the null hypothesis. Using the graph, you say that the p-value is outside the rejection region, so therefore you reject the null hypothesis. What about using the z? If you have to use z to make a conclusion, what is the red z equal to? The red z is equal to inverse norm. And then you have 1% on the left, and then mean is 0, standard deviation is 1. So you go to second vars, and then you use inverse norm. The area you input 0.01, and then mu is equals to 0, standard deviation is equals to 1, and this is equals to negative 2.326. And then using the z to make a conclusion, you say that the red z is less than the orange z. So negative 2 is less than negative 1. Therefore, you fail to reject the null hypothesis. And another way to say this is the test statistics is outside the rejection region. So therefore, you fail to reject the null hypothesis. So let's say that. So we fail to reject the null hypothesis H0, and then we cannot prove HA is true. So that means we are not able to reject the claim, cannot prove HA is true. Okay, let's say you never took stats in your life. Do you understand what this sentence means? You never took stats in your life. The answer is you don't, right? You know what it means because you took stats. Can you write a sentence that everybody understand? The answer is sure. So cannot prove HA is true. That means we have no evidence to show more than 60% of the customers are willing to buy another Toyota. To buy another Toyota. So this sentence, everybody understand. So to make the language even easier, the company is trying to exaggerate and say, okay, look at our customer loyalty. We have so many people that are willing to buy another car from us. And then after we study, we collect the data, and then we analyze the data, and then we said, all right, we failed to reject H0, so that means maybe you told the truth. So I am trying to prove that you are lying, right? So after looking at all this evidence, and my conclusion is I am not able to prove that you are lying. Maybe you told the truth, maybe you are not. So we fail to reject H0 means the statement remains suspicious. So there at least 60% is suspicious. Okay, so we just make a conclusion, and then the next step is, how about a confidence interval? I would like to use confidence interval to support myself. So let's draw a line. So confidence interval, what percent should I use? So we have 1% alpha. So that means I have to use a 99% confidence interval. And then the formula is you have a p hat. So this is a point estimate, and then you plus or minus that follows normal distribution, right? So that's why you use c half alpha, and then you multiply the square root of p hat 1 minus p hat divided by the sample size. And then you might ask me, hey, if you look up to the test statistic formula, you use p naught, but this one you are using p hat. So to explain this, you are using p hat to estimate the true proportion p, right? If you plug in a p in there, or that means you already know p. Then why do you still want to estimate? You are trying to estimate the truth, right? If you know the truth already, why do you still estimate the truth, right? So that's why in a confidence interval formula, you use p hat. Of course, we don't do any math by hand. We do this on calculator. We go to stat, and then we are looking for one proportion z interval. On my calculator, on the left is line A. The letter A is right under 0. 1 prop z in. So 1 prop z in. So you select that simple menu. How many success? 110, and then out of 200 customers, and then your confidence level is 99%, so 0.99, and you hit calculate. So when I hit calculate, I have so on your TI84 plus, you should have 0.45939, and then comma 0.4664, 0.61. So if you round this up to percentages, you can do how about this? 46% and 64%. That looks way cleaner. What does that mean? That means we are explain the confidence interval. That means we are 99% confident that the true proportion of Toyota customers willing to buy another Toyota or buy another Toyota falls between 46% and 64%. So simply speaking, you are trying to estimate the true proportion P, the population proportion. You are 99% confident that the true proportion P is between 46 and 64%. And then in this problem, I have a H naught, right? So I have a H naught. What is the H naught? What did I propose? I propose more than 60%. I propose at most 60%. So let's switch color again. So we are trying to verify. We propose H naught P is greater than or equal to 60%. Is this inside or outside? So 60 is inside, right? We have, if you make P like 80%, that is outside, of course, but as long as I can find one number that satisfies the inequality and satisfy the inequality, then that is an inside. So we have H naught greater than or equal to 60%. So 60% is inside. So that means H naught can be true. Then we fail to reject H naught. All right, so that's That's all in the problem. Let's take a look at the screenshot. So in the screenshot, we have a stat test, right? So you go to stat test. So you go to stat, and then you go to test. You select the 1 proportion z test. This is what you're supposed to see. The true proportion is the P naught is 0.6. We have 110 out of 200, and then you select the not equal, the less than is for HA. So this is for HA, and then you calculate, you have the P value that is greater than alpha, and then you have the one-sided test, and then for the confidence interval, you select stat test, and this time you're selecting the 1 proportion z interval, and then you input the x and the n and the c level, you calculate, and then you have the confidence interval. And then in case you are asked to draw a picture for the confidence interval, so this is what you have to do. So they will give you a bell curve, and then you have 99% right in the middle. And then the lower limit is 0.45939. The upper limit is 0.64061. Okay, and then what is in the middle? In the middle, you have the true proportion, you have the sample proportion p hat, so which is 110 divided by 200. Of course, they approximate that for you to 0.55. So 0.55. So you have 0.55 plus or minus margin of error to get the lower limit and the upper limit. All right, so that is the end of this video. If you think my instruction is clear, let me know in the comment below. Like the video, share the video for me. See you all in the next one. Signing out for now.